All right, here's another one. The next lesson came out as the next lesson is physical properties of matter. So we talked about classification of matter, and we talked about particle theory of matter. So now that we've sort of gotten the theory and the hocus pocus not being able to see but describe parts out of the way, we start looking at how we can describe things that we can see. The first way we can describe matter is through its physical properties. In other words, using your five senses, what do you notice? Some examples you already know, like if I ask you to describe describe your binder. Some of the things that you can do is talk about its color. I'm not sure you would ever talk about its smell unless there's a musty smell to it. You might talk about how shiny or dull it might be. You could talk about how smooth it might be for its texture. Malleability, I'll hold until later. You can talk about its state, whether it's solid, liquid, or gas. There's other ways you can describe it, like its melting point, like here, boiling point, we'll get to that. Brittleness, how well does it crumble? Or is it very durable? Is it flexible? Things like that. Words like malleability and another one, ductility, which you will actually see on a different sheet right here. Ductility, right here, okay, is typically reserved for metals. Malleability is things like being able to roll out like dough into sheets. So an example of something that's really malleable is aluminum. Why? If I had a hunk of aluminum, I could take a hammer to it and start like mashing it down, okay? And this will become flattened and flattened and flattened until it becomes a perfectly flat sheet, right? Aluminum foil. So that is a very malleable material, malleable matter. Ductility is slightly different. As opposed to flattening it this way, it's actually checking how well it can stretch. If I take my hands, okay, and I grab this material on both sides and I pull, am I able to pull? Sort of like silly putty. Am I able to pull and let it stretch out? The main way to describe it is, can I stretch it out into wires? That would describe ductility. If I cannot, well, it's not very ductile. Just because you're malleable doesn't mean you are ductile. And just because you are ductile does not mean you are malleable. They are two very different things. So please be careful. Another way you can describe physical properties is by describing them using numbers. And that is what we call a quantitative physical property. Like, for example, water or ice will melt at 0 degrees. Water will freeze at 0 degrees. Boiling point. Water boils at 100 degrees and vapor will condense into water at around 100 degrees, right? Conductivity is another way we can describe how well something conducts. Viscosity, again, we can put a number to viscosity just as a rough scale. Hardness, there actually is a official scale called the Moore scale. And relatively speaking, diamond being the hardest material is rated as a 10. So anything as just as hard as diamond or close to diamond will be a 10. A fingernail is considered a 2. So you're gonna have to use your imagination a little bit to see what number that might be. Solubility can be calculated based on how well something dissolves or how much of something that you can dissolve in solvent. Typically, solubility is described as some grams per milliliter of water. Okay, so it's still a number. So that's why solubility is considered quantitative. Lastly, we talk a little bit about density. There's going to be a full lab on it, so hold tight, but that's another number we can describe. Moving on. So just as a way to practice, to keep things light and to not stress students out, I had a quick activity. I got 15 cups. So there were literally 15, coffee cups, and they were covered by a cue card. So you don't know what the contents were. And inside there was something that I put in. Students would reach their hand in there blindfolded or with their eyes closed and use their fingers to write the texture, brittleness, and hardness of the material. And then afterwards, they can look at it and describe its color, luster, and if there is a smell, odor. It was a pretty fun, very quick activity. It also gave me an opportunity to see where some errors might be. And particularly in things like texture, some people describe things, let's say, as sandy. And that makes sense because it was sort of very, very tiny granules of crystal-like substances that did feel a little sandy. But at the same time, it's not the best habit or a best practice to describe something by comparing it with something else. So, because if I describe something as sandy, I could go one step further and say, hey, what does sand feel like? If you say something describe as something feels like sand, well, what's sand feel like? So in other words, you can go a little bit more specific. So you can describe something maybe as gritty, right? Or gritty but smooth, right? Granular but smooth. All these different things sort of fall under, and it's more appropriate than just calling something sandy. Following, after we had an exercise for that, I moved quickly into chemical properties, the different ways we can describe something as it changes into something else. A chemical property describes the ability to change into something else given a certain situation. In other words, react. You can describe something, some object's chemical property that describing how well it reacts with water, acid, oxygen, in other words, like rusting, okay, etc. You can describe the ability to burn as a chemical property, and so on and so forth. Okay. And we had a bit of an exercise there for that. We filled this in. The answers to these questions you can find in class as well. And let's see. That was it. That was first part of the lesson. The second part of the lesson, we moved into a density lab. So we filled this in together. And then I had everyone work through an assignment for me. We collected data together as a class, and then we graphed it just to see some wow factors going on. What is going on here? Anyways, and then we had some questions that everyone had to hand in. So I believe I specified this when you said what you had to catch up on. Let me describe what you could have done here to catch up. So to fill in the sheet, this is specifically for the class to use as reference. If each ball had the same mass, right, which box would weigh more? So clearly, you have the same space, 3D space, but inside it, there are more balls. So it's clear to say the left one is gonna weigh more because there's more balls in it, right? Box one has more balls in the same amount of space or volume. So in other words, instead of saying it more balls, since they all have the same mass, you can say box one has more mass in the same amount of volume. This is a physical property of matter called density. So it gave a definition of density. Literally, it's the mass of a substance per unit volume, right? Is that similar idea of that riddle you might have heard when you were a kid, like what weighs more, a kilogram of feathers or a kilogram of bricks? Well, the answer is they both weigh the same. However, a kilogram of feathers would be a huge bag, right, of feathers, whereas a kilogram of bricks might be like this tiny bit. Why? Because this is clearly more dense. There's a lot more molecules or atoms packed in the same amount of space. Right? Let's continue on. I digress. Sink or float. The density of oil, I believe the oil that I just said it was maybe 0.8 grams per milliliter. Water is exactly 1 gram per milliliter, and glycerin was approximately 1.2 grams per milliliter. So per same amount of volume, glycerin is heavier than water, which is heavier than oil. Density is very important in governing how substances interact. When two or more substances are put together but don't mix, they separate. For each unit of volume, denser substances are heavier. When substances are mixed, the denser substance will sink. This forces the less dense substance upward, causing them to float. The force, this invisible thing pushing upwards on the less dense substance and allowing them to float, is called buoyancy. Okay. And so that's generally the summary of density. We're going to look at the math and how I would like the class to approach mathematical calculations. Why am I asking you to go through this rigorous 5-step method? It is largely because I need everyone to, in a sense, prepare for the physics section of things. You need to prepare yourself. Let's continue. Density. Here's a formula: mass divided by volume. And if mass is in grams and volume is in milliliters or centimeters cubed, the density is going to be grams per milliliters or grams per centimeter cubed. It's pretty important. So we're going to try employing this formula using this guess method. I need everyone to write down the givens, write down unknowns, equations, and then solve and give me a therefore statement. Let's try what that looks like. Oh, let's see what that looks like in practice. Example 1, the mass of a crown is 490.6 grams. So write down the mass. The volume is 55 centimeters cubed. So write down the volume. This was given. Is the crown made of gold is the final question. In other words, what's the density of gold? The unknown that they're looking for is density. And so you can put a question mark there. The equation we're going to use is D equals M over V. Do I have to rearrange it? No. S, I'm solving. I plug in the numbers that I know. And if I solve it, I don't have a calculator on me, but I believe the answer becomes closer to like 9 point something. I think grams per centimeter cubed. Okay. And therefore statement, 9 point something versus pure gold being 19.3. So clearly this crown is not gold. So you say, therefore, the crown is not 24 karat gold. The same applies here. So you can try that on your own. But you see how I am trying to fulfill every single letter in the word guess. Okay, try that. So as a class, what we did was there were 3 stations. I got everyone to measure out a 3D block or a cylinder or a rectangular prism or a cube, whatever. Tell me what the mass is using a scale, and then you measure the volume because it's a 3D object. You can figure out the volume using length times width times height or whatever. And you use guess to calculate the density. Station B is the exact same thing, but the shape was irregular. It wasn't a block. It was actually like part of a cone. If you use your problem solving skills, you could probably figure out the volume of this like cut off cone, but we don't have time for that. Instead, what I did was let everyone throw this irregular shape into a small can of water. And now when you throw that in, that water will start to overflow. And the amount of water that you can collect from that overflow can will be the same volume as the volume of my irregular shape. And that's why there's this little tutorial on how to read a graduated cylinder, how this is the meniscus, this little curvature. And you're going to see me do a demo when you come back. There's a little curvature and you can't read it up here. You have to read it right at the bottom of the meniscus. Now, calculating the mass using a scale, calculating the volume using the water, you can calculate density one more time. Station 3 was a unknown metal block, which you had to calculate the mass for and do this once again, and then see if you can identify what type of metal it was made out of. We also did an exercise showing how density is just like the slope of a graph, which some students may not have done in math class yet, so it's not as important at the moment. But I just wanted to link it to some people because it might be helpful when they do go to math class. And of course, we know that science is the firstborn of mathematics. So here we go. With that said, all of the calculations we have done, even in this video, should help you in calculating the density of these questions. And then hopefully what I've spoken, what I told you, what I've discussed about density up here with the oil and water and separating and what floats and what doesn't will be of use to you when you answer questions D, E, and F. Okay, so that is something that I would expect from you. Get it into me as soon as you can. But of course, no rush at the moment. You are still catching up, so don't feel pressure. Just do a little bit every day until you catch up. Okay, hope this video helps. I will see you later.